Hello, my friends. Welcome back. In the previous videos, we talked about linear, polynomial, and nonlinear regression models. And we saw that when the relationship between the data is not really linear, then we have to use the nonlinear data, which is like most of the problems in the real world. But the main issue with the nonlinear regression models, if you remember, was that you had to plot the data, look at the relationship between the data, and come up with a function based on your knowledge and experience that would fit in there perfectly fine. And then use Python to train your regression model based on that function, right? In a previous example, we used the sigmoid function because we saw that it would probably match your data format. But the problem is that we don't necessarily have that knowledge and experience, right? Maybe I look at the data and I think, okay, I don't know what function to use. Then how can I solve my problem? That's the topic of today's video. Today, I'm going to show you a way that you can, use the regression models, right, to solve your problem, linear or nonlinear, without knowing like an exact function that would fit there. Let's get started. So we're going to use 3 different libraries, probably new to you today. So from scikit-learn neural networks, import MLP, not a classifier, but MLP regressor, right? If you don't know what neural networks are, if you don't know what an MLP is, don't worry about it. MLP is multilayer perceptron. It's a model of neural networks, but I will make a new video, like a whole new video based like for neural networks. So we're going to go over that later, but for now, let's just use that. So basically all it does is that it gives us a regression model based on a MLP neural network. The second library is going to be scikit-learn datasets, and I'm gonna import make regression, right? I don't really want to use like a CSV file and like read it in pandas or something. Obviously we can do that still, but I thought why not we learn something new too, right? So basically what this library does is that it makes a data set for us for regression purposes. And the third function that I want to call from scikit-learn model selection import chain test split. So you remember in the previous video we were defining the mask and be like, hey, like if it was less than 0.8, do this to make our chain data and like our test data and stuff like that. Now we're gonna see another way of doing that. And in case we want to plot something, I'm just going to go import matplotlib.pyplot as plt. So this should be good for today's purposes. Before we forget and before you forget, please subscribe to my channel so that you support me and you will also be notified when I upload the next video. Anyway, let's continue. I want to start making my samples. So I'm just going to use the make regression function, and it has different values. It says number of samples int equals 100. So the default is 100, right? You can change that obviously. And then like you can see number of features is that by default is 100, and so many other things in here. I'm just going to go number of samples equals, I don't know, 20 samples for now. And number of features, let's say 4. I want 4 features. Let's look at the data that we have now. Print X and print Y. Okay, let's see what it looks like. When I print the data, we can see something really interesting here. So when you look at the Y value, it's an array of just 20 different values, right? that makes sense. Like 1, 2, 3, 4, 5 columns and 1, 2, 3, 4 rows. Yes, it's exactly 20 values because we have 20 samples. But when we look at the X data, it's a list of lists, right? You can see it's a big list, and inside we have lists of 4. So what it means is that this is the first element of the first feature. This is the first element of the second feature. This is the first element of the third feature, and this is the first element of the last and the fourth feature. This would be the second element of the first feature, and so on and so forth, right? Um, so far, so good. And if we want to plot the data, right, how can we do that? If I go something like, I don't know, plt.plot x and y and plt dot show, I don't really expect this to work because they have different sizes, right? But let's see what happens. If I run this, okay, it did it, but it did something really crazy, right? Um, which is not really useful. Like all the features are just like plotted that way. So plot is not maybe the best option. Let's do scatter. See if that works. This one should fail for sure. Yes. And as you see, it says X and Y must be the same size because you're scatter plotting now, right? When you say just plot, it just like connect everything with a line. As you saw, it was a really bad example. I'm just going to keep that in a video so that you will see it won't work. But anyway, it's not working like that. But let's say we want to see how, like the relationship between the data, then how can I plot that? Let's define X for feature 1, right? That's an empty array. I want to extract all the, samples for the first feature. As you see, like basically I want the first column. It has 20 columns, right? And like 20 rows for 20 samples that we had and 4 columns for the 4 feature. I just basically want everything in the first column, which is all the samples for the first feature. Let's see how we can extract that. I'm just going to go for sample in X. So the first time this for loop is being executed, it gives me these 4. The second time, it gives me the second 4 values. So then say for sample in X, X for feature 1, that append, what am I going to append? I'm going to append sample because like sample is this list of 4. And because it's feature 1, that would be the first element, which is element 0, right? And now that I have that, I can actually go here and be like scatter X feature 1 and Y. That should fix our problem, right? Let's clear this thing and plot this. And yes, so it plots it. It says, okay, this is like how your data looks like. Feature 1 based on the Y values. If we increase the number of samples, let's say like 200 samples, and we look at the data and like, oh, okay, so I'm starting to see a pattern. Like maybe everything is around, like if I draw a line here, probably everything was going to be like very close to that line. Let's see if we keep increasing it, what's going to happen next. See, yeah. So like making samples, like if you draw a line right in the middle, like most of the samples are around that line, right? Okay, cool. Not where we worry about for now. It's just like we made our data, we saw how our data looks like, and now let's move on. I'm just going to comment this out because we're not going to need them. Now we have our X and Y, right? The next thing we need to do is to split our data, right? Make some, training and test data, stuff like that, as we saw we did before. So I'm just going to go chain. I'm not going to use the mask thing as I said before. We're going to use this function in here, chain test split, right? So I'm just going to go x chain and x test and then y train and then y test. These are the variable names. You can come up with anything you want, but basically these are the 4 outputs of this function, right? And here I'm just going to go x and y. So I'm giving this my x and y, the database, the data set that we generated, and it's splitting everything for me and giving it back. And then obviously, like, you can say like the test size. You see, like, it's suggesting me that like I can come up with a float value or none that says, okay, like, how do you want to split this, right? I'm just going to go test size equals 0.2, which is like use 20% of the data for test purposes. Okay, now I have that. And now we can actually define a regression model. So regression equals, this time we're going to use the MOP regressor. So in neural networks, when you're trying to train a neural network, you have to repeat the training process a few times, and each of those times is called an iteration. So you want to define the maximum number of iterations, right? Because the way it works is that it has a forward and a backward propagation, right? So each of these is called like an iteration. And as it goes, it tries to figure out and like make modifications and justifications so that it reduces the error. Usually, the higher the number of iterations, the better accuracy. But that's not always the case. But anyway, I'm just going to go max iteration is 100, for example, right? So it makes this model for me. And I'm just going to go fit that model. As you saw, you can do that in a different step. That's okay. Like, you can go to the next line and be like regression that fits. That works too. But let's just do it here. And I want to say use X train and Y train to train this regression model, and do that for 100 iterations, right? And now that the model is trained, we can actually use it to predict our data. So I'm just going to go y test, and because this is the predicted value, let's actually call that y pred for predicted value. That's regression that predict. Well, the input to that would obviously be x test, right? We used x train to train it and x test to test it. So this is like the predicted values, right? And let's just run that, see if that works. Okay, it says it's a warning. First of all, it's not an error, so it should be okay. And the warning is maximum iteration 100 reached, and the optimization hasn't converged yet. It's okay. It's just like giving you a warning that, hey, I'm still working on it. 100 is probably not enough, right? But let's see how good our model is. I'm just going to go from, you've seen this before, scikit-learn dot metrics, import R2 score. Let's actually move this up. I put it down there in the previous videos, but let's actually do it the right way now. And now I'm just going to go print F statement as before. R2 score is, and then obviously R2 score of, these are the predicted values, and the Y test, these are the expected values, right? And now we can see how good of a model we trained, right? Let's do this now. And what gives us the warning, and it says your R2 score is 0.93, which is good, right? I have like 2,000 samples, 4 features, and it only took it like 100 iterations, and it's giving me an R2 score of 0.93, which is really good. If I increase the number of iterations, if I go to 500 iterations, for example, and run this thing again, let's see what the known R2 score is. It's 0.998. This is more accurate than any of the previous models that we've used so far, right? Linear, polynomial, and nonlinear regression with the sigmoid function, right? In the previous videos. And like, this is the highest and yet the easiest probably, right? It's interesting. So this is how it works. So I showed you how to use the MLP regression, so that if you wanted to use the regression model and you didn't know a function that would fit the nonlinear distribution that you had perfectly, then you can obviously use this, and it's a very easy thing to do. You can keep playing with the number of features and the number of samples. Like if I reduce the number of samples to 200, because it's less sample, I'm expecting to see I don't know, lower R. Yes, as you see, the R2 score drops because now I just don't have enough samples. So my model is not perfectly chained, right? And so yeah, you can keep playing with these value, like go to 0.4. So you were still like decreasing the number of chaining samples. So should probably drop below 91%. And it says, oh, it's really bad. It's returning like a negative value. So it was really bad. Let's not do that. Anyway, you can keep playing with the values here, a number of features, see how it works. And yeah, that's about it. Let me know if you had any questions in the comment section. But before I say goodbye, I want you to do something. I want you to use the previous data set that we had, the one that we used the sigmoid function for. I think it's the previous video in my channel. And try to train a multi-layer perceptron regression model for that example, and see like compare the performances. And yeah, that should be a really good exercise for you. Anyway, thank you for watching me. Hope you enjoy your day. Have a good one. See you in the next video. Bye-bye.